Okay. So first two classes we have discussed basics of reliability, concepts and definitions, and last class yesterday we discussed basic probability judgment, where we discussed the basic definition of probability, then independent events, mutually exclusive events, and finally we went on to probability distributions, right? Where we saw that the probability distribution can be characterized by mean and variance, okay? And standard deviation is simply square root of variance, or variance is the square of standard deviation. So today our topic is binomial distribution. Did you solve all the problems? Please represent. Have you tried solving? At least putting the Google, see the answer. Okay, at least you should do that. So don't solve yourself. Simply put it in the Google, it will give you the relative AI will give you a step-by-step solution. Okay. So today our topic is binomial distribution. After this, next 6 classes over 2 weeks. 2 classes capacity of this table, 2 classes loss of load indices, and 2 classes will be loss of energy indices. So basically COT 2 classes, LOE mostly we will go for loss of load expectation and LOE, loss of energy expectation. So these 3 are the most fundamental for power system reliability evaluation. Power system reliability evaluation. Okay, these are the most important parts. So that will complete our module 1, and the very foundation on which rest of the course will stand. Okay, and for most of the work that you will see in research papers, they will be based on this book, LOE, microgrid, reliability evaluation of microgrids. But then the same concepts will be used. Okay, so it is essential that you understand these 3 concepts very thoroughly. Okay, but today we will see the other prerequisite for doing all this, that is known as binomial distribution. You know this, you just revise it. Okay. So what is a binomial distribution? Binomial distribution is a discrete distribution. It's not a continuous distribution. It's a discrete distribution where the outcomes are only 2, either success or failure. Okay. So this can be, you write the heading binomial distribution. So this can be understood by means of the single toss of a coin. The outcome is the single toss of a coin. The outcome can be either head or tail. Okay. Each having probability of occurrence as 1 by 2. Okay. Right? Right or single toss of coin, outcomes are head or tail, and each probability is half. Now this can be written as the all possible outcomes can be represented as pH plus pt or pH plus pt to the power 1, because the number of trials is 1 here. The number of trials is 1 here. Okay, so pH plus pt to the power 1. Write it down. When the number of trials is 1 for a binomial distribution, all the outcomes can be written as pH plus pt to the power 1. Okay, so this is tossed once. Now, when the coin is tossed twice, so you have 2 trials. In the first trial, it can be either head or tail. In the second trial, it can be either head or tail. So we will write the set of outcomes as the combination of the outcome of the 2 trials. So it can be either both heads, first one head, second one tail, second toss. First toss tail, second toss head, first and second both tosses tail. So there are only 4 outcomes. Okay, or you can say the outcomes are HH, TT, and 2HT. Okay, two combinations. So we are taking combination, not permutation. Permutation, these are different. HT and HH. HT and DH are different in permutation, but we are taking combination only. So there is only one group, so 2HT. So this is written as PHPH, 2PHPT plus PTPT, which is P square H, 2PHPT and P square T. And hence, when it is tossed twice, the outcomes are written as PH plus PT square. Okay, so this is PH plus PT square. Okay, so when we extend this, it becomes P square H, 2PHPT, P square T, like that. And this is very important because this can be written in terms of combination formula. Okay, which can be extended for n systems. Okay, n trial systems. Okay, similarly, when the coin is tossed thrice, the outcome is PH plus PT to the power 3, which when expanded says PQH, 2P square H and PT, P square H, 3P square H PT, 3PH, P square T. Okay, and PQP means that when a coin is tossed 3 times in sequence, you can have 3 heads, all 3 heads, or you can have all 3 heads only once. Whereas there are trials where you have 3 trials where you have 2 heads, 1 head, 3 trials having 1 head and 2 heads. Okay, the sequence may differ, but we are bothered about the combination. Okay, so this is point number 1, beat 1, when tossed once, when tossed twice, and when tossed twice. Okay. So this is the expression of a binomial distribution. Okay, right? So we'll come to the general expression for binomial distribution. So we'll come to the general expression for binomial distribution. So binomial distribution, you can write down this. Point number 2. Binomial distribution can be expressed by a general expression P plus Q to the power n. P plus Q to the power n, where P can be considered the probability of success and Q can be considered the probability of failure. Okay. Write it down.